Hello, and welcome to our concluding session of the IEEE Big Data Competition Science4cast. My name is Mario Krenn, and I'm a group leader at the Max Planck Institute for the Science of Light in Germany, in Erlangen. This competition was done together in collaboration with the IARAI, with the Institute for Advanced Research in Artificial Intelligence in Vienna. So let me give a very short review of the idea how this competition started. The main goal is to find out how we can make computer programs to inspire surprising and interesting ideas. So for that, we need to know what it means to be surprising and interesting. And this is obviously very subjective and depends very much on one's previous knowledge. So the question now is, how can we get this previous knowledge into a computer, that the computer can actually use it and give us now our surprising and interesting suggestions? So I was puzzled very long with these questions until I found this really inspiring article from computational sociology. So this was a collaboration between computational sociologists and biochemists. And here the idea was the following. The researchers see research programs as links between scientific entities in a knowledge network. And they have built up from millions of paper and patents an evolving semantic network that carries kind of the research strategy of the global collective scientific community. What they have done is using vertices as concepts in biochemistry, and those concepts are in their case the names of biomolecules, and the links between concepts are drawn when two concepts are investigated together in a scientific paper. And what they found out is that with the simple idea, you can get actually a lot of insights from this dynamic network. And in this specific paper, they have shown that with supercomputing computations, that they could suggest actually more efficient collective research strategies, how the collective scientist community can be more efficient in research. And I found this absolutely fantastic and wanted to apply it to other fields. And this is where we are now. Now we are applying a similar idea to the field of artificial intelligence. And this is what the Science4cast competition is all about. We have we built up a semantic network that consists of roughly 65,000 concepts in artificial intelligence, and all of the papers that have been published in arXiv on the topic of machine learning, artificial intelligence, and advanced computational methods. Now, when we have the dynamics, or when we get the dynamics from these papers, we can create an enormously large evolving network. And the question is whether we can use this evolving network actually to predict what will happen in the future, what scientists will research in the future. And this question can be formulated in a network theoretical sense, namely, which two concepts that have never been investigated together will be investigated together in the next few years. And this is exactly the main aim of the Science4cast competition. And I would say the competition was very, very successful. We got 72 contributions. At least 40 or 45 of them beat my simple baseline. So, which means they are extremely high quality. And even those that were that didn't beat my simple baseline, they were very, very interesting. They had a lot of new ideas. And with these ideas, we can now go further and develop this idea of inspiring new ideas in science further. And today we will kind of celebrate this whole competition, all of the contributors, and we will have a number of talks by the winners, the first three winners of the competition, and also a number of special talks of very interesting approaches that were not among the top three, but had very, very interesting ideas how to approach this problem. In addition, we have two super interesting talks, one by Professor Rose Yu, who is an absolute expert in spatial temporal dynamics prediction using neural networks. She will show how to use graph neural networks to solve related problems. And then I'm very excited to have also Jacob Foster as one of the speakers. He's actually a computational sociologist who inspired a lot of this work. By showing how to build up semantic networks, and he will talk about science and the production of collective intelligence or unintelligence. That will also be very interesting. So now we start with the first talk by Yichao Lu. He is at Layer 6 AI in Toronto, and he has won the competition. And I'm really interested in listening to his approach to the problems, what he encountered. And especially during the talks, we have a lot of time we have a lot of time for questions. So if you have questions, please write them in the chat, and I will read them and ask the speakers. Also, as a very last note, I would be very happy to work together with all of you on one concluding paper where we can actually show all of these results applied on similar data sets, and show which methods work best, which have advantage in this regard, which can be used in this type of question. So this would be really great, and I'm very much looking forward. I will contact you afterwards by email.